So it takes the last 5 years of financial performance for the asset, right? U.S. dollar standard, traditional operating strategy. And then you're building out the Bitcoin financials, essentially. The numbers speak for themselves once you get, 24, 36, 48 months into the process. Once they see that, it's going to sell itself. To your point, we need that proof of concept. It's still very, very early. But
what kind of data should be collected in that proof of concept? That's a question that immediately jumps out at me. You need to meter how much you save them, how often you had to service it, right? All of these things. How many times it failed? How many times the backup had to kick in? Or what else comes to mind?
Did they have to replace any parts? Did they, how they've been maintained? Is it anything different than my normal system? Yeah. That's the thing. Like, all they will continue to do is do what they've always been doing because that's easy. They hit the easy button. If you can make sure that you tell them, like, look, I haven't had any issues with this. Here's proof of this.
How many callbacks?
Can I call back? Absolutely.
Yeah.
Setup cost, time.
Yeah.
Right? So how much is it going to cost me to get it going, and what's the time it's going to take to implement it?
Yeah.
That's what, to your point on the commercial side, that's what they want to do. There's no emotion like you have on the resi side. How much is it going to cost? How much time is it going to take? Right?
Similar to, I know a big thing at the end of the year for miners was the 100% depreciation. Is there, tax implications that can even make the bottom line look?
You could do some crazy stuff.
Yeah, so if they have to, on a large scale, purchase it.
This is a really good point, because my understanding of that tax law is it is short-term depreciation, but heating infrastructure is long-term infrastructure. Where do you draw that line? Where do you slice the hardware to say, this heating element, the actual circuit board that I'm going to upgrade every 36 months, may be eligible for that tax credit, but the broader infrastructure is not. Seth is not in the room, but I wish he was here because he's a CPA. We'll have to ask him. Yeah, that's a great point. Yeah.
Well, and then that gets into are you modularizing it in a way that it's like I can depreciate this little chunk? Because when you think about either those immersion systems, what are you going to depreciate? You're not going to depreciate the tank and all the infrastructure. All you're going to do is work out that 19J and throw in a 21 and it'll fail in 2 days. I'm not bitter.
Somebody hand the dollar question.
Mike, what is on your mind? So Mike is a sales engineer at Long Building Technologies, does a lot of manufacturer rep work for large commercial buildings. We've had a bunch of extensive calls, but what you're hearing here in the room, what do you think?
Yeah, I think what you're talking about resonates pretty deep as far as form factor, right? We need documentation to submit to engineers, to owners to get approved. We need wiring diagrams, install manuals. When you have all those things, I think a lot of this stuff becomes a little easier over time because you have a sales rep network already in place all over the country that knows how to sell equipment. They have the relationships with the engineers, with the manufacturers, with the owners, and they sell different kinds of systems, right? So they're going to be able to identify, okay, this kind of system could make a lot of sense in my market for this specific owner, and they're going to go sell it, but they don't have a way to back it up right now. Right? So the only time it really is seeming to make sense is direct to owner, where there's one decision maker that understands it.
Top down.
Yeah, you're selling to a Bitcoiner who wants to just stack the Bitcoin, but if you remove that, and say somebody that's more sensitive to their operating costs, how do you model that? Because you can't sell them speculation. You just hold it forever, and the Bitcoin price is going to go up, and everything's going to be great because you're going to pay everything off in 5 years.
Which makes me think about you, Dan, and all the modeling you do, because ultimately this is an economic driver. Model it out is my understanding, so we know what to spec, how we can cut costs, how we can make this building efficient and save money. There's a whole new knob introduced here when you're saying, well, here's the model, turn this knob for how bullish you are on Bitcoin.
Right.
You need a life cycle cost analysis, and because they're going to want a net present value. They want to know what their IRR is. And it has to be done in a way that you're conservative enough to meet them and not just say, it's going to go to $1 million, but just have those different scenarios available to them. What if it doesn't do that? What if it's different things? If the difficulty changes? That adds a lot of parameters to announce. Yeah.
Do you think it eventually, that kind of toolkit gets baked into the work that you do in the building?
I think it could be.
It could be.
It could be.
Okay.
It sort of be like a standard range for all these metrics.
Yes.
Yeah.
Well, but then to your point, if you're a sales guy and you're coming in, how does that model change? Because the model changes every 10 minutes.
I know.
I mean, and I don't mean literally every 10 minutes, but it's adjusting one way or the other every 10 minutes. Right? It's either faster or slower. Very, very, very. So you're slowing down, and all of a sudden you turn off 30% of the miners in the country.
This is a great point. So,
so when you're modeling and you're selling, you're walking in with a model from 3 months ago. How often does that have to be? How often does that happen?
I have an anecdote about this. So Bart, who's on your panel tomorrow, he is an investor, and he's the top-down guy, right? He's a Bitcoiner, doesn't need to be convinced. They're building a commercial building in Boulder County, 10,000 square foot, mixed use, co-working, some shops downstairs. And he's told the MEP team, the developers, we're putting a Bitcoin boiler in this building. We're doing it. And thus far, we've been working with the MEP team I have. We had to specify a dumb resistive electric boiler on the drawings to get it through permitting. And there is a Bitcoin miner just next to it that is not connected on the drawings. And then after the fact, we're going to replumb it. So he's being the guinea pig, right? And on the modeling front, I delivered him a model where I estimated, Bitcoin CAGR 25% year over year, conservative, hash value difficulty 40%. And it said, when Bitcoin was 110 grand, this model said that your boiler is going to pay off this construction loan in 15 years. But now Bitcoin's half that price. So I'd be curious to open that Excel model.
That's when you just turn up your CAGR, right?
Exactly. Right. And that makes me think about the metrics, and maybe you know about this more, Chris, is it dollar per square foot? Like, what kind of language do we need to communicate this to these type of clientele, right?
Yeah.
You can't come to them and say, well, if hash value does this, technically,
Yeah, no, I don't, this is not, fully baked, so poke holes in it, please. But it's a metric of something of like Satoshis per square foot, right? Where it's a measurement of excess energy that can be allocated into sound mining.
It makes me think of COP that was created for the heat pumps, right? That measure, that coefficient of performance, which is a measure of how thermodynamically efficient the machine is. We almost need that for this new type of heating technology, I think, to communicate to the building space.
It has to be per square foot because when we create a building, put a cost to it, an estimate, they put cost per square foot. That's what they look at. And they're always trying to value engineer these things and tweak it and try to get peeled dollars off. So they're going to look at it compared to the Satoshis per square foot and see if they can get it in balance or tilted in their favor.
Well, and the other thing is, again, those metrics are going to change constantly.
Yes.
It's like, I have that little brain being on my desk. My wife laughs at me every time she sees this. But, I'm looking at that, and the hash price is just, it's soul crushing right now. And, some of the problems is if you did your model at 120, what are you doing when you go and you pitch it? And then do you pitch it just super bear case?
And it depends who you're pitching to, and if they want do they want to hold the Bitcoin? Do they want to have their own wallet? Or are you taking on that Bitcoin risk yourself and just selling them the heat? And can you offer two different solutions?
Yeah, definitely. I talked to some pencil developers. They didn't even want Bitcoin.
Yeah.
Give me a really cheap water heater, you can keep all of it. Cool. And that's what they wanted. Yeah.
That's better.
Yeah. Which is a risk it's a gamble for your company.
Yeah, it is a gamble for us.
Right.
But it's value for them too.
Totally. I think that might be a way to do it. I mean, the other low-hanging fruit here for the modeling is buildings that might already be trying to electrify anyways. If they're already doing electric resistive, now typically to me that would indicate they're going heat pump route, just because of a lot of regulation and mandates. But if they're already implementing electric resistive, then it's a done deal. I mean, it's the same cost. There's just an upside, and then you don't have to get bogged down on the percents of the savings and everything there. Yeah. Okay.
Well, and that's the part where what Nicholas was talking about, where you're talking about that the recovery. what am I talking about? And they curtailment.
Curtailment, yes.
But when you're dealing with the negotiations at that level, again, you've got the three-way stack. You got the heat, you got the SAPs, and you got the potential recovery.
And that's why I think a big benefit to this emergent technology in the broader building space is actually like the smart angle than just so much the cost savings. Because if you can say, this system we're going to put in your building makes it like a hybrid car. You still got your natural gas system, but you also have this electric. Maybe you have solar panels on the roof, and the control setup that's sold to them is doing all the economics in real time. It knows their flux, it knows their power costs, it knows the demand response, it knows all of this. And in that sense, the building's just deciding in real time, I'm going to heat the cheapest way possible. And then you don't have to, convince them of we're switching to this. I like this framework, and I'm curious what comes to mind in the commercial space, but for the residential, where I'm focused on right now, is like, I really want to just put a black box in a house that makes the home hybrid, right? And we don't say rip out your propane or your natural gas. We say you got an energy storage. These are the people buying Tesla solar roofs. They've got energy battery backups. You know what I mean? They've already converted all their natural gas stoves to electric. That's a huge list of people that would go that route just because they want this smart building, right? This more smart, not just your light bulbs and your blinds, but in the energy stack. What do you think about that?
That's where you need to talk to the BMS people, trying to control the Honeywell. They're doing yeah. They're tying together the solar, the different heating systems, how it interacts with cooling and everything. So you can build your own way of controlling those things, but they're already doing it to some extent. So you tie into what they're doing.
I would actually recommend. So yeah,
As former hashrate president,
I would say not those two. The only reason why is that they are like nitpicky proprietary controls, and actually once those people get installed in buildings, they are known for basically sending the customer over an hour
to come service it.
To literally like pick up a phone call. First of all, it's a 3-month minimum usually to get to know the
$1,000 truck pulled out.
And on top of that, all their controls are proprietary. If you go to open source like Niagara platform,
so BACnet is open source.
But BACnet is on Niagara platform.
All you need is a control board that talks BACnet to JCI, Genesis, or Honeywell. You don't need Johnson controls on board. All they're reading is the BACnet points, and they're writing and reading those points. So I don't think you need Johnson involved, other than it's just another BACnet device.
So
it's just another device on the network.
So you're saying typically do need them involved though to integrate with them, so like either their what they're looking at, connecting it in at a point.
Yeah,
and they still need them on site before.
Yeah, of course, but I'm just saying that most HVAC controls, the equipment has its own control board, and Johnson's just like reading and writing those points.
So you're saying all we need is an interface that connects.
You just need the control board
into that.
They have BACnet capability to read, to talk to that.
Because the building already has a BMS brain.
Correct.
We just need to communicate with it.
Yeah, I've got tons of equipment on site that has controller, long nose, but it's got controller, you can talk to your controllers, you can talk to Johnson through BACnet, and you don't need really Johnson there other than to maintain their system.
So the open nature is the part where we need something that can talk to the top end then?
Yes. And
BACnet seems like a huge first step that I
see. I think the whole industry is settled on BACnet. I don't know anybody using Modbus or anything else.
No, not
very
rare.
rare. You get industrial controls that are doing that, but for
Modbus is typically like within their proprietary controls. So for example, you may have a controller that communicates to the VFD.
Yeah.
Through Modbus.
Right.
But then that VFD is communicating to the BMS system. Even if it's monitoring only. There's BACnet over IP. But like BACnet IP is really
it's kind of like a nested web of how things are communicating to one another.
It's faster, it's got a quicker pull time, it has a faster receive if you give a command. Like if your places that are still on twisted pair or even like BACnet over twisted pair, you can hit a thing and you're literally waiting 15 minutes for it to propagate through the back end of the system for it to even like start to do what you wanted. And within that 15 minutes, what it was trying to accomplish might no longer even be needed. So it's this like insane time delay that like that's one of the, when I'm on a job site commissioning systems, if they have an old, like antiquated thing, that's one of the first things that I would know, like, alright, cancel the rest of the day.
What other immediate first steps come to mind after, sit on here for 15 minutes? In terms of, there's a lot of challenges. It's really the takeaway. It's almost like pick your poison, right? Where do you start? Is I guess what I'm getting at. BACnet to me seems like a very important one.
Yeah.
I feel like I'm gonna have to solve it for this commercial project in Boulder because they're not like, how am I gonna link it to the rest of the stuff?
So like I said, you may want to throw up Niagara. Niagara is open source control base, almost like an app store. So you can create protocols and like sequences.
So it's a competitor to BACnet?
No, it would be more of a competitor with Johnson and Honeywell and Siemens. Yeah,
it's more open source hardware.
Hardware and software.
Yeah.
So you can use any control provider within, defining parameters, and then anyone can technically create protocols that are like sequences or, hey, this is a thermostat meeting, so this is the hot water.
So it's kind of like open system.
Yeah, commercial, like industrial commercial.
Like I said, the most like layman term comparison would be the app store. Like you could download an app that can do something. And you don't have to necessarily know how it works, although we can show you guys this.
So the sequence meaning you install this Bitcoin heating infrastructure in the building, and then you download the app that has the sequence for how this is meant to communicate and integrate into the rest of the stuff on site.
Correct. And over BACnet, if each of your devices has its own API, has its own IP address, you can actually have it basically auto-configured. So it can say, okay, I have 3 of these on the network. I'm assigning this ID 1, 2, 3. I'm simplifying it.
Understood.
And then it would pull that in as data points, and now it knows exactly how to communicate with those and can integrate that into those. So as long as your controls are set up to be modular and scalable, meaning not like, only do this one, it's like an N, like a 1 through N type of configuration, we can basically auto-update and then figure out the switch.
Assuming we get control and integration, then the next thing that comes to my mind is someone monitoring and maintaining this system. What do you all think about where to start in terms of educating a workforce on a new type of hardware, a new control setup? Do you go to the trade schools? Do you need the proof of concepts and the white papers and the data first? I have no idea how this process works. Does anyone have any thoughts on this? Yeah.
I think one of the easiest things to do is pull hardware out and ship it back, right? So like I'm in the mindset of like you make it as easy as possible in the field, so you don't need a highly trained field team. Then you can pull from anywhere, right? I think if you need a highly trained in-field team, then be prepared to spend a lot of time hiring and managing people.
Right. So no specialized service.
You may want to also throw on there fault detection diagnostics. Since everything is going to be on here connected through some kind of controls and we're collecting data, miners are actually one of the best for just spitting out like what it's doing.
I mean, it's a computer.
You're already doing it with a computer.
Yeah.
Like that's traditionally the hardware.
You can record anything you want.
Anything that's an integrated system.
You're right.
Like a mechanical.
Your heating element has temp sensors. Your heating element.
Right. So how does that like
theoretically, you know your machine's down before you know your machine's down.
Correct.
Right. So like we can actually be like, hey, your machine just went down. We're gonna send someone out in a few hours.
Yeah.
Cool. Thanks.
So FDD is the term. FDD, fault detection diagnostics. What you could do is basically, it's not just, hey, your thing failed, it failed this way, which means it's most likely just that you here.
So a company has to build the hardware and software stack with these features baked in before you can start calling the regular service techs in your area, right?
Not necessarily.
Not
It depends on how advanced the existing control systems are. So if you have a BMS that's already got like an Overwatch FDD, then basically you just need to communicate what does normal operating look like, what does failure look like, what does this failure mode look like, what does this failure mode look like. And there's actually some really interesting things coming out with AI that it will kind of figure out some of those for you.
I'm sure.
Because it's just basically watching what happens, and then it will learn later, and then it will like self-update. So it's like, hey, I remember the way that this fell last time, it was actually this.
Right.
Or it will look at other data points in your system. So maybe it's a failure at what appears to be a failure at the miner, but really you just got a slug of like too hot of water, and so it shut it off out of the heat protection mode. But the rest of the system was seeing a water temp that was within range. So that AI can actually start to pick out some of those like asymptotic, like weird things that happen and figure out, hey, this is how it failed last time. This is what it probably was. Either just try restarting, try restarting and see what happens. It might just turn back on, or it failed this way. It's probably this part. Tell your tech when it comes out to have it.
And this is, I think, a direction that makes a lot of sense for hash rate heating. As compute heat, right, with an internet connection, we should be leaning into these types of things so that you get more benefits to communicate to the clientele, really, of why you're upgrading to this system, moreover than just you're going to hold a Bitcoin and be happy in 20 years. What else should we talk about?
Well, and that's, to your point, very much in the sales pitch of your furnace is going to tell me service here. You don't have to add anything.
Does that already exist in the commercial space with a good BMS system?
Yeah.
Yes, it does.
So like right now, I'm actually arguing with our BMS where it's not sending emails correctly, but that's a whole other thing. But it will, I mean, even if this is a Java application written in like 2002 or something, it's the worst interface I've literally ever seen. I'm not sure.
Well, keep it.
Anyway,
I know you don't.
It actively will send out emails anytime there's like a specific thing, like a filters out. Well, I'll send an email to this person or this other. There's an overtemp. It's going to go here.
And that's
chillers
typically
down.
going to a maintenance technician or
It's
something?
going to go to either the building manager or a specific maintenance tech or whatever. So to your point, it'd be exactly the same. Even in an old school, if you're not doing any kind of phone home stuff, you know, it's built in where you can literally just be, here's the email address of the person that needs to come out and service this thing. But in this case, when you're talking about something that's a literal computer, there's no reason that you couldn't have in the pool split area of a, let's say, open source firmware, some kind of a maintenance panel that is a completely separate thing that explains, like, I'm going to get this set of error messages to a maintenance tech because I don't want the maintenance tech to know about my pool being down or whatever. Maybe the pool information is proprietary to the client. Maybe the client doesn't care about the Bitcoin at all.
We actually did that.
There you go. There you go. Figure it out.
Yeah, so we have a dashboard where you manage a fleet of devices. And there are different views for different people, like the building owner and the regular technicians inside, the IT people inside of a company where they can't see the financial data, but they can see what's happening with the miners. And then outside contractors like plumbers and they can see that each other devices are servicing. And if there's an error, it shows them an error codes. And then there's instruction on how, like, what probably is the problem and how to fix it, or how to everything that comes up, and then go to the device, scan the QR code on the device, and then it do this.
And so in that scenario, you're relying on partnering with a network of service providers, really, to understand that system so they can go service those calls.
And those service providers, like we talked about on the panel before, they get a little bit of a cut.
On the Bitcoin, yeah. Exciting.
You want to add another term to the word, CMMS, computerized machine management.
They can integrate into
So that typically will tie into the FDD as well. So the FDD will trigger and say, hey, there's something going on. Let me create a maintenance line item. And
they'll make a work order.
Communicate through that whole
Technician to go check it out.
And Ryan, this is very much how like work orders for Bitcoin mining operations work, is my understanding, right? This is an automated process at this point in the industry. At Compass.
And then you're going to find whatever issue is causing the problem and address it right then and there. So whether you actually in a commercial mine it's all, but I guess it's something that they should be aware of.
Yeah, it could be a decentralized mine in that sense.
I'd say also the more you can take off the on-site facilities person to do, the better. If they were just getting a stream of error emails, they're just going to shut the machines off because it's not going to work for them. So
yeah,
that is absolutely
Or to that point, if you have 1,000 alarms, you have 0 alarms.
You get it.
No one's
Yeah.
So I'm a service guy. Just wondering in this room, though there might be more. And I love the sound of all this stuff, but I'm wondering where's the army of me? Like
we're right here.
All of these emails get generated. All of this, the system is down. what happens when, because all these plumbers and electricians and mechanical guys are all, as we all know, 5 of them are retiring and only 2 of them are coming in.
I mean, if you're
Where do we get the army of me? Where do we get the army of that guy?
I mean, if you're talking commercial, industrial, you already have that with E&Is on site or people that service those type of customers. Because we replace boards and stuff on all kinds of stuff all the time. So it's just another board. It's just another. Do I have 12 volts here where I should have 12 volts? Do I have an input and output? That really, it's all the same stuff for that side of it. Residential will be a little different, but commercial industrial has a team of people that do this all the time, and half the equipment, I don't know how it works. I just know that I can tell when a board's bad, and that's really how it goes. I mean, I don't know how half of our equipment in our plant runs, but I can definitely diagnose that it's got an output, or it's receiving input, and the output doesn't work. So the board's probably that.
So we don't need to.
I don't think you
raise an army.
You don't have to just because it's a Bitcoin miner. It's still a circuit board. It's still got a power supply. It's still got an Ethernet connection. You know, those type of things. They're all
Miners
pretty.
can be modular, right? Like,
Yeah.
if one goes down, you just swap it out.
Correct.
Yeah.
Well, so I don't think it's too big of a reach. I mean, yeah.
I was gonna say some of that, like as far as swapping it out, you're almost at a point depending on what level you're at. The pricing if it comes down.
You might just replace the whole machine or
You're not-
whatever.
You're not
yeah.
gonna go all the way
You're not
down.
going to try to get to the component level.
I can tell you for us, if there's anything that ever happened with the miner, you unplug the miner, you reconnect it,
Yeah.
you reconnect lightning, and you're back.
Well, you always cycle power first.
Well, I guess the point that you
I'm saying, at the point that you need
I think so.
Yeah.
Meanwhile, the guy on site just ups and over.
Yeah.
Now, the other thing I was gonna say was, like, between a building that's big enough to have an on-site facilities guy that could theoretically be running all the thing, you're gonna have a smaller site that's not gonna have an on-site facilities guy with a strip mall with like a nail salon and it's like, you're not gonna have somebody that's gonna be able to do that kind of support on site there. So how do you manage that? That's the part where the next level, like you just talked about, you can have a whole other industry where we built that thing. I'm the IT guy. I'm a Bitcoiner. I have my IT staff. It can be an entirely new industry for people like me to train my own guys to do all of this type of support. Where now my architecture firm that is entirely dependent on somebody signs a check and hands it to me, and now I'm done. And that's the last money I see from my client until we build another building in 20 years. We've got residual income on a constant basis because the company is investing in Bitcoin. We're investing in staff to be able to provide all this support. So it's almost like you're talking about bottom up, top down, who's doing the train. Like there would be an incentive for my company. I'm pitching it to my boss without looking at him.
But he knows.
If you're looking for an example, you can look at continuous commissioning as an example, right? So as you start to connect things more and more, where you could view the system over any internet connection, right? You could literally be on the opposite end of the world and still see a file. There are systems that are known as continuous commissioning. So basically, before a problem gets bad enough where there's a problem, you would be looking at, all right, are we starting to slide out of our okay operating range? And then that would trigger an event for them to say, hey, talk to your guy on site. But those, remote monitoring are typically set up as a subservice, right? So after the project is done, but the key to that is you integrate it into the initial part. So like, a lot of the codes that are out there require commissioning which are above a certain threshold. How do you do this commissioning? Right? If you don't have any DMS on site, it's either your systems are not sophisticated enough where it's going to be hard to commission, or it's the exact opposite, where actually you have a pretty integrated system, but your controls are non-existent or very much inferior for what it should be.
I see.
So if you set it up where your actual long-term control system is configured with the end in mind, so it does your active controls, but it can also be used for your initial commissioning, and it can then be used for your continuous commissioning. Your one hardware set now has multiple business takeoffs throughout different parts of the project and operational cycle.
Tom, you asked how to get it out there. That's kind of how this whole thing just spun out.
And I was also watching Matt, I think it was, what was your name? Chad and Justin up there just now. What I see as a top-down, bottom-up is the fact that you've got to get it on the drawings. I mean, that if it's not on the drawings, it's not happening. And in order for that to happen, you have to have engineers who are willing to do that. And I've got some slightly bad news there. There's just not a lot of forward-thinking engineers out there. So what we've been doing in our company is trying to network with like-minded people that are actually thinking about heat recovery, actually thinking about not just peak loads, but the full 8760 data set of a year-long data and how do loads fluctuate. What are the coincident loads of this cooling process and this Bitcoin mining at the same time? Because if they're not fully coincident, what happens, right? We have to create heat or we have to reject heat, period, end of story. So obviously I think the top-down approach is architecture. The bottom-up approach is customers that are like, hey, how can I save? And what I think ultimately happens is once a project goes down, now you have a case study. So the fear factor for the next client goes down because you're like, look at how much money we save back in. And obviously it's a whole other level if you're trying to say, plus you're getting dividends on Bitcoin. But even before that, just the heat transfer is extremely lucrative. There's not enough engineers thinking about it. They're like, I'm going to oversize this so that it's never going to fall, and that's how it's going to be. So it's all about networking with people who are like, no, we're going to think about it, and at least our clients are going to be happy, and then we're going to turn that into a case study for more clients. So that would be just my suggestion.
We got 5 minutes left here before I got to go down and get ready for the next panel, but go ahead, Ryan.
I was going to say, to be fair, a lot of those problems that you're talking about are already not exclusive to what we're doing.
Sure.
Right? Whether it's a gas-fired system, a propane-fired system, an electric system, an oil system, engineers are going to design so that they're not the ones getting sued when they're doing that.
I guess the same
not all of it.
sense for the lack of tech situation. That situation already exists. I guess it doesn't. There's tech in the field, whether it's Bitcoin systems or whether it's regular old natural gas fired.
I was going to tell you, look into an organization, Mechanical Contractors Association. They've actually been talking about this for a long time.
Oh yeah, I'm a big fan of microworks. Like what those guys are doing is amazing, and the ship is starting to turn. I mean, 5 out and 2 in, everybody's starting to know that number. Like that's a big deal. I just kind of wish I was 18 instead of trying to get out of the other end, because all of a sudden I can see a lot more money in the future than I did in the last.
Well, AI might take everyone's jobs and get us more tradespeople.
Yeah. And maybe I need to get some young guys under my wings and start making money off of them too.
I do think there's a point there, which is it's a unique offering, and if you can find a target market where it's lucrative and it saves money and it's benefiting the community, then you train those techs and you get the first guinea pig, and then hopefully, I don't think it scales almost like Airbnb, where it started in one city and then it took over before they went to the next city, right? I don't think this is a top-down where someone's going to build a product and say, boom, we solved it for North America, or we solved it for Europe. I mean, it's hyper-local, hyper-specific. And once those benefits are starting to be documented, that's when other people will start to pay attention. Before we wrap here, gentlemen, is there anything else that you'd like to cover? Or this is a great list. There's a lot of work to be done. It gets me excited because now with the hashrate heat pumps under the 256 Foundation, I'm really going to spend the next part of my year focusing on getting some people from the broader energy and building space to support the foundation so we can issue grants to start solving these problems. This is a takeaway. Last year we kind of just listed and said, hey, I hope this is done by next year, right? Well, it turns out people like to get paid to do work, so I'm hoping we can issue some grants to actually solve a lot of these efforts. BACnet, open source communication for mining integration, that makes perfect sense for the 256 Foundation and the hashrate heat pump movement. But over to you.
The other thing I would add, you talked about it on your project here, is that you had to put something on paper that didn't exist, like having a approval either through hashrate or through the jurisdictions. I mean, that's a barrier. You have a barrier like that.
If we can solve it in Boulder County, we can solve it anywhere.
Yeah.
But yeah.
I can't believe you're getting that done.
Talk to Bart downstairs.
That's nuts.
Yeah. Well, very good. I mean, this has been an awesome workshop. I think there's a lot of work to be done, but I'm happy we were able to get everyone together. Big room. Yeah. Cozy. At 1:25, so in 10 minutes here, Dylan's going to start a control panel, which will be quite interesting. Talking with a gentleman, Bob, who's doing everything 24-volt contactors analog. He's had no issues for 3 years. There's no it's as little computerized as possible, all the way to dealing with Home Assistant, trying to marry it into everything in the smart IoT space. Yes, in the event room. And then we'll talk with Kanan about, he just stepped out, but Kanan and Leo and Scott 9000, who made the BitX, the open source BitX project, we're going to be talking about all these cool things you can do with Bitcoin miners, because that company has...
Canon's a great example of a company that you talked about building something that doesn't look 3D printed.
Boom,
That's
right behind you.
That's the company that can build, that's the type of company that can build that kind of stuff. I mean, that looks amazing.
Mm-hmm.
You know, I think there's something, I mean, it may sound obvious, but like everyone that's spoken here, they all like their own little niche, and like the level of like knowledge is off the chart. Like, don't not talk about this at the office or with a client or what because you think they're not interested or if you're gonna talk over them. I was like kind of like self-censoring myself the last half a dozen years on this topic.